to be looking at several things. The main thing is triangle similarity. But before we just jump straight into triangle similarity, there's some topics we need to refresh on. Okay, ratios and proportions. I need y'all to stop your side conversation, close your laptops. Thank you. Okay, ratios and proportions are not a new topic. This is a topic we are refreshing on to get ready for our new topic. Okay, so first of all, let's refresh on what a ratio is. Okay, a ratio, it says, stylus here. Okay, you're comparing, it's a comparison of two or more quantities, two or more values. Okay, so we can write ratios. Let's say our ratio is 3 to 2. Okay, so that's one way you can write it is with the word 3 to 2. 3 to 2. Okay, you can also write a ratio instead of the word 2. You may sometimes remember seeing it with a colon, 3 to 2. That's still read as 3 to 2. It's a 3 to 2 ratio. Okay, anybody know the last way y'all represented ratios? Say again? Over, yeah, fraction, good. So 3 over 2, okay? So that's what we are going to be focusing on is that last one, fraction form, okay? So when we have ratios, okay, we're going to write them as fractions, okay? And we know that fractions can be simplified, so that means a ratio can be simplified, okay? So we're going to practice that as well. So in this first example, it says a music store has 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 trombones in stock. Write each ratio in simplest forms. Okay, so the first ratio they ask for is trumpets to violins. Okay, so let me do some color coding here. So 40 trumpets. So I would say 40 over, and then it said violins, there's 24 violins. So 40 to 24 is the ratio. We can reduce that when we're reducing ratios or reducing fractions. You're looking for a common factor that you can divide out. What are both 40 and 24 divisible by? What? Say again? Not 20. 20 will go into 40 evenly, but 20 won't go into 24 evenly. They are divisible by 2 and 4, but that's not the greatest common factor. So if you want to do it piece by piece, if you don't know the highest greatest common factor, you can do piece by piece. So if I were to divide out a 4, that would leave me with 10. And what's 24 divided by 4? 6. But 10 and 6 can still both be reduced because they're both even, aren't they? What, I can divide out a 2 from both of those still, can't I? So you keep reducing until you can't anymore. So if it takes you a couple of steps to get down to that, oops, sorry, that's not a 2. We divided out a 2. That leaves me with 5/3. Okay, so we divided out a 4, and then we divided out a 2 from both parts of our ratio, the top and the bottom. Okay, what you could have done instead of dividing by 4 and then dividing by 2 again, you could have just divided by 8. 8 goes into both 40 and 24. But like I said, it's okay if you need to do it in multiple steps. You still get there in the end to the ratio of 5/3. So for every 5 trumpets, there's 3 violins. Does that make sense? Okay, now let's do flutes to clarinets. So flutes was 51. So I'm going to say 51 on top. And then clarinets. Why did I underline violins over here? Clarinets, let's do green, that's 39. So 51 over 39. They're not even, so I know it's not divisible by 2. So then I say, okay, well, maybe it's divisible by 3. And they are. Those, if you try to divide both of those by 3, you get an integer, which means it reduces. So if I divide out a 3 from both of these, I get 17 over 13. Now 17 and 13 do not have a common factor, okay? So I can't go any further. That's as much as I can reduce it. All right, and then this last one says, how about trombones? There's 16 of those. The trumpets, and trumpets were red. There was 40. So 16 to 40, I can reduce. I definitely know I can reduce by 2 because they're both even. So if that's what you have to start with is just 2 each time and keep doing it, you can do that. Or if you see a higher number that will go into both of these, you can start there. Say again. 4. Yeah, 4 will go into both of these. So again, if I reduce by 4, that would be 4 over 10. Can I do 4 over 10 further? I can divide both of those by 2. That would be 2 over 5. Good. All right, and then last but not least, we've got violins. There was 24 of those. To the total number of instruments. So how many in total? So I have to add the trumpets, the clarinets, the violins, the flutes, and the trombones to get my total number of instruments. So if I add all of those up, let's see, that comes out to 170. So there's 170 total instruments. Again, I know both of these are even, so I know they'll divide by 2. So if you don't know of something higher, start with that. And that would, dividing by 2 would leave me with 12 over 85. Okay, and then you can check, but there's nothing else that both of those are divisible by. So that's as much as we can reduce it. Okay, so a ratio is just setting a fraction for something, some value to another value. You're comparing two quantities, then you reduce if possible. Okay, reducing fractions. Do you know what your calculator will do for you? Your calculator will do this reducing. If you type in 40 divided by 24 into Desmos, it's going to tell you it's 5/3. Or depending on the settings, it might give you a decimal, but then you can click the little fraction icon and it will change that decimal to a fraction. And when you do that, it gives you the most reduced fraction. So you don't even have to be able to do this reducing by hand. It's good. I want you to be able to do this by hand, but you do get a calculator and the calculator will reduce for you. All right, so now a proportion. So you may recall back in intermediate, y'all learned about proportions. It's when you set two ratios equal to each other. Okay, an equation, so that means set it equal. If you have an equation, you have an equal sign that states two ratios are equal. Okay, so we write a proportion like that. I'm just going to use letters for this. So I'm going to say A is to B as C is to D. And if you want to write that in words, how you read a proportion, you can put it in words. You read that as A is to C as B is to D. That's how you would read the proportion. Now, when you are setting up a proportion, you are typically going to know 3 of these 4 pieces. You have 2 numerators, 2 denominators. One of them is missing. You are going to cross multiply. Okay, it's called the cross product property, but it's just cross multiplying to solve. So when we say cross multiply, remember that means Some of you may have called it the butterfly method because you kind of make a little butterfly wings when you cross it like that. So the A times the D and the B times the C. Does that make sense? Y'all remember that?
Yep.
All right, so let's try that. So in number 5, I've got 4 over x, or 4 is to x as 2 is to 7. So to solve this, I'm going to do the x times 2, which is 2x. And I'm going to do the 4 times 7, which is 28. Now, how would I get rid of that x? Or sorry, how would I isolate that x? How would I get rid of the 2? Yeah, that's 2 times x. The opposite is to divide. That's what you're doing every time when you cross multiply. You're going to multiply the 2 that you know that are diagonal from each other and then divide by that third. So instead of showing this dividing by 2 like this every time, some of y'all are going to do this kind of all in one step. So 28 divided by 2 is 14. And that would be x. That's the value that would make these ratios equal. And you could check that. You could type in your calculator 4 over 14, and it will reduce it to 2 over 7. 2 over 7 is the reduced version of 4 over 14. It checks out. But you can always check it at the end, plug that number back in, and type both the left and right side into Desmos and see if they're the same. They should be if you solved it correctly. All right, so same concept here. I'm going to multiply the 2 that I know. It's the 19 and 12. So I'm going to multiply 19 times 12, and then I'm going to divide by that third one, the 10. So this is what I mean when I say you might want to do it all in one step. Some of you will just do that. You'll go ahead and divide the 10 over, okay? So 19 times 12 divided by 10 is 22.8. Y'all remember doing this? Okay. All right, now these get a tiny bit more complex if it's not just x. So if it's the missing piece is just a variable, just x or y or a or b, whatever letter, it doesn't matter. But if it's that letter is what's missing and it's by itself, that's how simple it is. Multiply the 2 that you know, divide by the third, the 2 that are diagonal, and divide by the third. Now, if it's not just x, you've got an expression here, okay? There's another way to do this. You can, again, set up the algebra like we did in 5. If I were to do that, the 2 that I know are 6 and 13. So 6 times 13 is 78. So 78 would be on one side of my equation. And then here, when I do 19 times x minus 1, I have to be careful because it's an expression. So I need to put those parentheses like this because that 19 has to get multiplied by the x and by the -1. If you're going to do it algebraically this way, this is one option. So that would become 19x minus 19 equals 78, and I finish solving. So I would have to add the constant over. So add 19. So I'd be left with 19x equals 97. And then I would get rid of the 19 by dividing. And that would leave me with approximately 5.1. That's rounding. It's a long decimal, but we'll round to 5.1. Now, I said that's one option. Now over here, remember how I did it all in one step instead of setting up the equation and solving for x? I can still kind of do that. I'm going to set up multiplying by the 2 that are diagonal, that are just the numbers. So 17 and 19. And then I would divide by the 5. But instead of just being done, like here, I divided by the 10. Here I would divide by the 5. But instead of equaling x, it's going to equal x plus 4. So then how would I get rid of that 4? How would I move that 4 to the other side? It's plus 4. What's the opposite? Minus 4. So I could write that minus 4 out here like this. So some of you may prefer to do it this way, where you're going to multiply the 2 that are diagonal, divide by the third, and then you're going to do the opposite of whatever's being added or subtracted to x. Okay, so since it's a plus 4, you end up subtracting 4. So you could type in 17 times 19 divided by 5 minus 4. And that comes out to 60.6. So you can decide if that way makes more sense to you, or if having to set up the equation like this makes more sense to you. Okay, I'll do one more each way. This left column will all be like the algebra way. Okay, so one more with algebra, I would multiply the 10 and the 9, that's 90. I'm going to do this one over here so it doesn't overlap. And then this way would be 20 times 2x minus, what is that, a 9? And then I would distribute the 20. So I would get 40x minus, and then and actually, I'm going to show you one more option instead of distributing. If you set up the algebra like this, instead of distributing like we did here in number 7 and then moving by addition or subtraction and then division, since this is outside the parentheses, butting up against the parenthesis means it's being multiplied, right? Yes? Yep. So I could go ahead and just divide the 20 over first instead of distributing it if you wanted to. So I could divide out the 20 and be left with 2x minus 9 equals, and then that would be 4.5, 4.5. Then I could finish solving for x. So then I would add my 9. And then I would divide by the 2. So that comes out to 6.75. If you distributed the 20 and then solved it, you would get the same answer. And you could check this by plugging it back in here. If I plugged in 6.75 times 2 minus 9, and then I checked that ratio, 4 divided by that is the same as 20 divided by 9. Okay, so you can always go back and check those. All right, so this last one I'm going to do in the method like I did on the right, where I kind of just did it all at once. So I'm going to multiply the two numbers that are diagonal, 12 and 15. I'm going to divide by the third number that's solo. And then I have to do, like I said, that's going to be equal to the 3x plus 4. So I would subtract that 4. So I'm subtracting 4 over here. That's like adding a negative 4, isn't it? Minus 4 plus negative 4, same thing. Okay, so I'm going to go ahead and calculate that. 12 times 15, 180, divided by 18 is 10, minus 4 is 6. So this whole side comes out to 6 equals 3x. This one has an extra step because of this, the coefficient in front of the x. So I have to, at the end, divide out that 3. So x is 2 for this one. Y'all feel okay about proportions, ratios? Okay, like I said, that should feel like a review. You've done ratios and proportions before. Okay, we just wanted to refresh on it. So if you flip over to the back, we're going to look at similar polygons and scale factor. Okay, now we touched on scale factor at the beginning of the week before you started your project because we talked about dilations. And when you dilate a figure, you're multiplying by a scale factor, right? That's what we talked about. So scale factor is not brand new, but we're going to talk about it again because it relates to similar figures or similar polygons. Okay, so what does similar mean? Similar means that they are the same shape, but not the same size. Okay, but more specifically than that, not only do they have to be the same shape, like they can't just both be triangles, they have to be the same type of triangle. Okay, with the same angles. So a right triangle cannot be similar to an equilateral triangle because they have different angle measures. Okay, so when I say same shape, different size, I mean like the same ratio of the shape. Okay, so it means that the corresponding angles are congruent. So the angles are going to be congruent. What does congruent mean? The same, exactly the same, equal. So the angles are going to be exactly the same in the two figures, but the sides will be different. The sides are going to be proportional. Hey, we just talked about proportions. And this is why. Because the side lengths of similar figures have to be proportional to each other. That means the ratio is equal. Okay, so the ratio of corresponding sides is what we call the scale factor. So we're going to get back into scale factor here in a sec. Okay, and then if the polygons are similar, then their perimeters are also proportional because perimeter is just adding all the sides, isn't it? So if the sides are all proportional, then the perimeters will also be proportional. Oh, I don't know why part of congruent got cut off there. There we go. All right, so again, scale factor, back to what we talked about before. Scale factor is your multiplier, okay? If you want to put that out to the side, that is your multiplier. It's what you're multiplying by to get from one value to another. And oftentimes, almost always, you're going to see it referred to or labeled as K. So to get your K, your scale factor, you're going to take your image divided by your pre-image. Remember, that's the vocabulary we learned last unit. The image is the new one. The pre-image is the original or the old one. Okay, so you're going to do new divided by old or new divided by original, however you prefer to think of that. Okay, so if I have two shapes and I'm told that they're similar, and I actually don't need to be told in words that they're similar because these markings tell me. See how A is congruent to D, B is congruent to E, and C is congruent to F? All the angles, all the corresponding angles are congruent. That's what makes a similar polygon. Those angles are all congruent. Okay, so the sides that correspond to each other, AB would correspond to DE, BC would correspond to EF, and AC would correspond to DF, right? Y'all see that? That's what I mean when I say corresponding sides or corresponding angles, the ones that, this is just a dilated image. This is the original image and it was blown up. It was enlarged using a scale factor. It was dilated. That's what we practiced on Monday, was dilation. So now they want to know, what was it dilated by? So we're going to take any of those corresponding sides and divide new divided by old. Now they tell us here, ABC to DEF. So they're saying ABC to DEF. So ABC is the original or old and DEF is the new. So when I do new divided by old here, I could do with the pink, 21 divided by 14. Or with the yellow, that's 12 divided by 8. Or with the blue, that's 15 divided by 10. And if I went to go check these in my calculator, all of them come out the same because they are all equal. They're all proportional. And all of those come out to 1.5 or 3/2. So that's my scale factor. All of those are equal and they come out to 3/2 or 1.5. So that is your K. That is your scale factor. And if you want to color code, that was the yellow, the blue. Oh, no, that was the pink. That was the blue. Okay. But here's why it says order matters right here. Because that was going from ABC to DEF. What if it was reversed? What if DEF was my original shape and I dilated to ABC? What type of dilation would that be if I'm starting with the big one? Be a reduction, right? It's getting smaller. Okay, so this is why order matters. Am I going to enlarge or am I going to reduce? So you have to pay attention to the order. So if this was going from DEF to ABC, all of those fractions would be flipped, wouldn't they? If the original is, or the new one is the smaller, this is what those would look like. So what's that going to come out to, do you think? If I just flipped all those fractions over, isn't it just going to flip my ratio? So instead of 3/2, it comes out to 2/3. Okay, so order matters. That's really important. The order matters. So going from the big one to the little one, I would be multiplying by 2/3. But going from the little to the big, I would be multiplying by 3/2. Do y'all understand the difference? So it says, what is the ratio of the perimeter of DEF to ABC? So from big to little. Well, we already said the scale factor, the ratio for the sides is 2/3. And we set up here, if they're similar, the perimeter is also proportional. So it's going to be the same as the side scale factor. The perimeter ratio is the same. So that is going to be 2/3 as well. Okay. Now, when we write a similarity statement, okay, if we know that these images are similar, okay, we use what's called a similarity statement. And the symbol for similar is just this little squiggle, a tilde on your keyboard. Okay, that little squiggle means similar in math. Okay, remember I put the reminder here for the congruent symbol. That's same shape, same size. The similar symbol is same shape, but different size. Okay. So a valid similarity statement must match corresponding angles and sides. So to write a similarity statement for these triangles above, so these right here, when you go to name your first triangle, okay, so we use a triangle symbol, and then you name it with the 3 vertices. So if I just do alphabetical order, that's probably easiest. So if I say A, B, C, triangle ABC is similar to triangle. Now, the order that I named the second one in matters. I can name the first one whatever order I want. I could have said BAC or CAB or CBA. It doesn't matter. The first one, I get to pick the order of the letters. The second one, I have to go in the same order that I went with the first. So I went A to B to C. So I went along the yellow and then the blue. I have to match that. So in this triangle, if I go along the yellow and then the blue, that's D, E, F. Y'all understand what I mean when I say you have to match it? You have to put them in corresponding order. So match the corresponding angles and sides. That's very important. Okay, so in this last one, we want to give the different ratios, the corresponding angles and the side ratios. Okay, so the similarity statement says JKL. So I'm going to mark J is the first one. What's the first one of the second triangle? What did they say? How did they name it here? PMN. So J is first, P is first. So that means J and P are congruent. So I'm going to mark them congruent. They used K second and then M second. So I'm going to mark those two congruent. And then they did L and N. So over here, angle L is congruent to angle N. Angle K is congruent to angle M. And angle J is congruent to angle P, because that's the order that they wrote the similarity statement. Now the side lengths, I have to do those corresponding sides. If you need to highlight, you can highlight, or you can just say red to blue. Red to blue. So that would be JK to PM. Those are the corresponding sides. And then I could do, okay, how about blue to green, blue to green. So that would be KL is to MN. And then, of course, you only have one left, but we'll go ahead and highlight it. Red to green, red to green. So that would be JL is to PN. Y'all follow? So you have to be able to identify which angles are congruent, which sides are proportional. We're going to practice it tomorrow. There's no homework tonight unless you haven't finished your transformation town project. Okay? Don't lose those notes. Bring them back with you tomorrow so we can use them when you're practicing.